coming up, life would not be the same on this planet without the Gulf Stream.
It brings heat, and it's why, for example, Northern Europe, which is the same level as Alaska in terms of latitude, doesn't end up with those really quite violent winters.
But scientists warn this powerful system of ocean currents is losing steam, with grave implications.
Do you think what's happening, or what potentially could happen to the Gulf Stream, is irreversible at this point?
Yes.
Loggers in Kenya get a stinging surprise while trying to chop down protected mangroves. And would you consider moving to Mars? The mission to get us there is underway, with astronomers developing a program they say could eventually help us populate the red planet.
It will take a very long time. We are talking literally thousands of years.
Just 2 degrees is on. Now,
let's say I planted an apple seed in Martian soil, watered it, used fertilizer. Would it germinate?
Well,
let us begin with current events. The Gulf Stream, for example, has a strong influence on the Earth's climate. But what is it exactly? Where does it go? Why does it matter? We'll get you up to speed on this fast-moving phenomenon. First off, behind every major current on the planet is a massive gyre, a large system of circular currents and powerful winds. They're so huge they can span from half to all an entire ocean. Earth has 5 of them, including the North and South Atlantic, North and South Pacific, and Indian Ocean gyres. The Gulf Stream is powered by the North Atlantic Ocean gyre, which in itself is a strong current of warm ocean water flowing from the Gulf of Mexico into the Atlantic Ocean. It continues up the eastern coasts of the United States, carrying warmth even further up to Canada and even across to Western Europe. The Gulf Stream also supports a massive amount of life. Fish like the bluefin tuna, the Atlantic salmon, and flying fish rely on it. But more than the fish it carries, it transports salt and nutrients to northwestern European waters, feeding many species. Its waters warm Florida's coastal ecosystems, and without it, England's climate would be much colder.
I've been down here doing this for the past 6 years. Started my own thing, or I guess 7 years. Started my own thing going on 5 years ago now. It has been getting a little bit slower and slower. Each summer we've been fishing. I'm not sure if it's because of the water temperatures or anything. I'm not sure how much it's even affecting us offshore-wise. As we're fishing the Gulf Stream, staying pretty steady around like 85 degrees or so. But as far as all of our bay waters, any near shore waters, everything's super, super hot. Up to, as you mentioned, 101 degrees water temperature. I did notice last week driving through the bay, a bunch of dead fish floating. I'm assuming that's definitely from the water temperatures. I also heard from some guys scouting around for lobsters this year that they've seen some dead ones as well, that I'm assuming is also from the water temperatures.
I reached out to Simon Boxall, a senior lecturer at the National Oceanography Center, to explain whether the Gulf Stream was in danger of collapse.
Doctor, I've been doing a bit of reading on this Gulf Stream, so I know a bit about its course, how important it is in terms of global temperatures and sea and some wildlife. Although I'll be honest with you, someone tried scaring me into doing this show about the Gulf Stream sometime last year, about it possibly collapsing. Have you heard such reports? And is that at all possible?
I think it's about semantics, and I think it's about discussing what the Gulf Stream is. The Gulf Stream itself won't collapse. The Gulf Stream is a sort of a circular motion. It's sort of the big sort of roundabout motion in the North Atlantic. And a spin-off from that is the thing we call the North Atlantic Drift. And that motorway of warm water coming up past Britain, past Northwest Europe, past Norway, and eventually going to the Arctic is important because it brings with it mild weather, it brings heat, and it's why, for example, Northern Europe, which is the same level as Alaska in terms of latitude, doesn't end up with those really quite violent winters. Now, the question then is that changing? The reason that flow occurs is because we get sinking in the Arctic. So if you like, it's like taking the plug out of the bath. It's drawing surface water from the Gulf Stream past Europe to the sink. And that then creates what we call the Atlantic overturning. So it's a sort of a big sort of sinking of water that then fills the deep Atlantic. The concern is that for that to happen, we need ice formation. And if ice formation slows down, then that flow slows down.
So then how did El Nino of the past year affect the Gulf Stream?
In practicality, there are many projects which are looking at trying to measure the return flow, trying to see, is this whole system slowing down? And there is some evidence that it is being affected by climate change. So what's the long-term effect? The Gulf Stream itself won't shut down. We might see a weakening of that North Atlantic drift, that flow of warm water that protects most of Northwest Europe from freezing over in winter. And that is a concern.
And what about the effect on animal sea life, marine life, if that does shut down?
Obviously, that has a dramatic effect. You know, our sort of sea life around the North Atlantic has been built on and has developed around the fact you get this warm water. And it brings a whole diversity of species to our northern shores. And again, the concern there is if that does shut down, then it will affect that diversity. It will affect some of the plants and animals that exist in our waters. There are some positives. There are some animals that prefer the cold. Cod, for example, would tend to migrate southward. But overall, it's going to have a fairly negative effect if it does happen. And there is still a big question mark as to whether it will or not.
La Nina, I believe, is supposed to start somewhere between July and September, according to some scientists. Could that help balance things off?
With El Nino, we've actually just come out of a big El Nino period. And we've had one of the most intense El Nino periods ever recorded. And certainly it was the fastest onset of El Nino we've ever seen. That has sort of collapsed now. We've gone back to what we call La Nina, which is a cooling period along the South Pacific coast. So that could have an effect and it could cool things down a bit, but we'll wait and see.
We know much of what's happening now is because of historical emissions. So do you think what's happening or what potentially could happen to the Gulf Stream is irreversible at this point?
Yes, I think, I think the damage has been done to a certain extent. The question is how, I suppose, serious is that damage? And so we've got to be careful that we don't turn around and say, oh, well, we're past the point in return, a tipping point. People talk about tipping points. Every day is a tipping point, and every day we move closer to bigger changes in our climate, in our weather. So it's really important that we consider that, and we don't just think we've gone past that point. We still need to reduce our carbon emissions. We still need to think about how we treat our planet.
Meanwhile, scientists in Colombia have been releasing biologically modified mosquitoes to combat dengue fever. The disease has claimed over 4,500 lives in Latin America and the Caribbean this year alone. It's part of a plan that's been in the works for almost a decade, spearheaded by the World Mosquito Program that enhances the mosquito's immunity against the virus. And results look promising. Dengue cases in the Colombian city Antioquia have dropped by 95% thanks to mosquitoes infected with Wolbachia.
Los mosquitos que son portadores de Wolbachia son mosquitos que generan cierta protección a la comunidad, porque la Wolbachia genera una barrera en estos mosquitos que impide que haya transmisión del virus del dengue.
Pero esta tecnología, de nuevo, está ideada para que una bacteria que es viva dentro de un organismo que es el mosquito, es vivo, puedan ser liberados para seguir preservando la vida.
Pues a muchas personas no les gustó, pues porque de primer impacto le hacer liberación de zancudos, pero a medida que se le está haciendo el seguimiento, que se le está haciendo la explicación adecuada, ellos lo aceptaron.
A pesar de la cantidad de desinformación que nos llega, nosotros tenemos todas las herramientas y toda la evidencia para demostrar y desmentir cualquiera de estas cosas.
Los dos nos explicaron que, pues bien, que era, nos dijeron que sí podíamos dejar que colocaran una trampa aquí, que era para un bien de nosotros, de la comunidad.
Imagine for a second that you're a logger and you're preparing for a long day of cutting down trees in an area that's forbidden. Well, you raise your chainsaw or whatever cutting device you're using, and you feel a burning sensation at the back of your neck. when you feel the second burn shortly after it becomes clear, you're surrounded by angry bees and you run. Well, that's the reaction Kenyan conservationists in Mombasa are hoping to get at least, as they execute a plan in the port city's mangrove swamps. It's an important endeavor considering almost 50% of the mangroves there are degraded, and the intervention could prove crucial to protect this important carbon sink. The conservationists have installed at least 11 beehives, and there's a sweet treat for the hard work. They get about 8 liters of honey per hive every few months.
Mikoko ilikuwa inakaa, tulikuwa sina amani, kwa sababu ni kitu ambacho unaona kwamba kinaleta hasara. Ijapokuwa binadamu hatambui. Wajua binadamu anapogundua kitu kwamba ni muhimu kwake, hatambui kwamba upande mwingine ni hasara. Naona sasa ilikuwa kwetu, hata wakati mwingine kwa tunasema jamani, si mkate kubwa muangalau mwache ndogo, lakini walikuwa wanaingia kama wanafieka shamba. Si kwamba wanapanda kitu, lakini walikuwa wanafieka kiasi cha kuharibu. Sasa majirani kama sisi hapo tulikuwa tunaambia jamani, kama mnafanya hivyo mnaharibu, lakini tunaambiwa si yenu, ilipandwa na Mungu, si mali yako.
Tulipotambua hii siri ya kuwa hii mikoko tumeweza kuilinda, na tunapoondoka tukienda nyumbani, nao ndio hao wanaingia wanakata. Lakini tulipoweka ile mizinga, ikabidi mizinga iwekwe mahali pa juu isipate kuonekana. Tena tuangalie ule mti ambao tunajua kwamba, unajua mwanadamu kawaida ataangalia chini, juu haangalii. Kwa hivyo tunaangalia ule ulio na majani, tunawekelea pale juu. Na akishaweka pale juu amefunga vizuri, yule mwenye kupita na kukata mti hawezi kuona. Yeye anaangalia ule mti ulio straight, ndiye ataenda kuukata. Lakini ule ambao amechikunda na majani mengi hajui. Na nyuki haipendi kelele. Wakati ambapo ameanza kukata tu, hata awe amekata huo ama amekata mwingine, nyuki ikisikia kelele lazima itamwandama mtu yule. Hatuna wakati wa kusema kwamba tunaweza kukata. Hapana. Tuko pale kutunza kwa wakati huu. Na ndio maana sasa tumechangia huo mkoko endelea pale, lakini nyuki imekuwa ni faida kwangu sasa. Kama mvua imenyesha vizuri, miti na maua vizuri, maua yanapatikana, hiyo nyuki inaniletea mazao, inaniletea pesa pia, naweza kuuza asali na nikapata.
There's a lot of excitement around the idea of leaving our planet to visit another, for various reasons, to determine the origin of the universe, to find a backup planet in case life on ours is no longer possible, or to simply quench our curiosity and thirst for exploration. Option 1, Mars. Many scientists hope the red planet could be our next home, and various experiments have been conducted to determine the possibilities. One entails testing whether a specific type of moss can be grown in the harsh Martian conditions. Mars's climate is not like our own. It doesn't have much of an atmosphere, which means it's vulnerable to deadly radiation and cosmic winds coming from the sun. But it's a fascinating idea to grow plants on Mars, right? I called Francisco Diego. He's lecturer of physics and astronomy at University College London.
Let's say I planted an apple seed in Martian soil, watered it, used fertilizer. Would it germinate?
Well, we need to be very careful here. The conditions on Mars are not that nice, okay? First of all, there is no atmospheric pressure, so there is no air. I mean, it's very thin. Okay? It's 100th of the air that we have here. So if you imagine a lot of the climbers to Mount Everest, which is only 8 or 9 kilometers high, they need oxygen. The atmosphere of Mars is equivalent of an altitude that will be 5 times higher than Mount Everest. We are talking about 40 or 50 kilometers. So
zero oxygen.
Is no air, okay? So whatever we do in the way of planting something on Mars or growing any kind of plant on Mars has to be inside a pressurized greenhouse. And there is no way around it. So this is very important to realize. And remember, all these plants have to be serviced by astronauts, by people there. So they have to also survive the same environment. You cannot have a plant there and then how you go and get it. So it is quite it's not that easy. So it's going to take time to develop techniques, but certainly these greenhouses need to be on the surface of Mars because, of course, you need the sunlight there. But you have the radiation there, there will be some kind of blocking the radiation somehow. The ultraviolet, you can block ultraviolet more or less, but the cosmic radiation, the solar radiation, you cannot block. So that's going to be a problem. While the habitats of people living on Mars, they have to be underground. They will have to be underground to prevent from solar radiation and cosmic radiation.
So this moss called Syntrichia canenervis, that I understand, that was grown under such controlled conditions. If it was grown in such controlled conditions, why are they saying that they can grow a plant possibly on Mars? What conditions resembled Mars under which these plants grew?
Well, these plants are not proper when they are like moss. It's like moss. It's a plant that is very resilient. They can survive in very difficult conditions, but still it needs the atmospheric pressure. It still needs the atmospheric pressure. I don't know which conditions they say they have emulated the pressure, but it's almost vacuum. You're almost in vacuum there. So I don't know if they have done the experiments properly, but certainly on the vacuum, any water, any liquid will evaporate, will actually sublimate. It will be converted into ice and fly away. So that's probably what happens on Mars, because Mars did have liquid water in the past. We know that. There's almost compelling evidence of that millions and millions of years ago. And that water is gone because Mars doesn't have a protection of a magnetic field. And it is the gravity on Mars is very weak in order to retain the atmosphere. And without the atmospheric pressure, the liquid water just sublimates and is converted into ice. We see ice, water in the atmosphere of a very thin atmosphere of Mars. There is water and there is mainly carbon dioxide. And you can see the deposit of water and carbon dioxide in thin layers in the polar caps when the temperature is very low. But the amount of water and carbon dioxide is very, very small.
I know a lot of people were hopeful that Mars could serve as a choice for us to escape the degradation that's happening on planet Earth. But from what you're saying, it sounds as though that's not possible at all, and that whatever environmental problems we have here, we need to fix here.
Absolutely, yes. Thinking about going elsewhere because our planet we have made it inhabitable doesn't work. In a way, we shouldn't explore space at all until we finish our own situation here on economics, on sociology, on environmental issues. We have to learn to live in a planet, for goodness sake, instead of going to another planet and export the same stupidity that we are doing here in our own planet. So we have to really put our act together as humanity and bring our act together. Not a single child dying from starvation, not a single tree is being chopped. No, I mean, this kind of stuff, we have to learn to change our way of life in order to, then we are ready. Yes, go to the moon, go to Mars, etc. But as a single humanity that knows how to live in a sustainable way everywhere in the universe, if you like, not the way it is at the moment. I agree with you.
Do you think somehow this plant, if grown in mass numbers but under controlled conditions, could add oxygen to the atmosphere, help create a Martian atmosphere, enough so to make it habitable for human life?
Yes, the process is called terraforming. In the way is taking a planet or a celestial body and make it the conditions similar to the ones we have here on Earth. So terraforming on Mars is going to be extremely difficult. It will take a very long time. We are talking literally thousands of years to terraform. I mean, it is a major project. I think it was called Total Recall. And when they go to Mars and they kind of build these enormous machines that eventually liberate air, and Mars becomes habitable at the end of the film. But it's not that easy. It will be something like that, but multiply that for by a million, and then you will have the kind of project that is required to create an atmosphere on Mars, which has to be replenished, because remember that Mars has very low gravity, and that atmosphere is going to fly away and doesn't have a magnetic field to protect you. So the solar wind will buffet that atmosphere and make it fly away. So that has to be replenished. It's a continuous process. Otherwise, we come back to,
Wow.
to square one because the atmosphere is going to be lost.
Interesting. You know, I also read recently that Mars has been declared unsafe for humans for anything longer than 4 years. Can you explain why?
I don't know. Yes, I read that in the news in the note. But another thing that people don't realize is that going to Mars is a one-way trip. You will not come back. Okay,
Why is that?
that is very important. I mean, to come back from Mars is I mean, once you are on Mars, on the surface of Mars, you are a very valuable resource. You are an asset. You have to do work there. And then if you come back, it's a wasted of resources and it takes months to come back. So you go to Mars and you will die there. That is the idea. Now, perhaps after several generations of people going to Mars, we will be a kind of coming back to the Earth, but essentially it's a one-way trip. The other thing that people don't realize and don't mention, for example, well, the exploration of the moon and the exploration of Mars are very similar in a way. Low gravity, no atmosphere, and very dusty environment. So it's very similar. One of the main projects that we have from NASA is the Gateway Lunar Orbiter mission space station. It will be a space station in orbit around the moon, and that will be something that perhaps should be better to apply to Mars as well. So you are in a controlled environment around Mars, and you can observe it, and then you can make little incursions on Mars to do something, and then come back to the orbiter station. Something like that may be possible. Another thing that is important is assuming that, yes, eventually we go to Mars and colonize and start growing things there, we have to be very careful. And a lot of, myself included, a lot of my colleagues, we are against that. Why? Because Mars is a pristine, or was a pristine environment before we started sending spacecraft. I was counting about 15 or 20 spacecraft already landed on Mars. So there is contamination. We don't want to contaminate Mars because we want to keep it pristine, because it has an enormous valuable scientific information that we need about the origin of life and the origin of life in the solar system, life on Earth. And if we contaminate it, we will never know what was the origin. I mean, we are looking at our own contamination if we are not careful. And perhaps it has happened already, because with a couple of, I don't know, a couple of dozen spacecraft landing on Mars, they cannot be sterilized properly, you see. Some of these spacecraft may still have residual organic matter that is really landed on Mars. And Mars has a little bit of movement in the atmosphere. There are winds, I mean, that very thin atmosphere still produces whirlpools and things. So there is movement of aerosols on Mars, and that contamination may be floating around all over the place. And we have to be very careful not to contaminate it, because we will be spoiling Mars. It's the same thing what happens in Antarctica, for example. Have to be very careful. Antarctica has life in a lake deep below the ice. There is the Lake Vostok that the Soviet Union and the Russians discovered, and that Lake Vostok may have very primitive bacteria. And it's very important not to go there very carefully, not to disturb any possibilities of life there. Otherwise, we're spoiling the evidence.
And that is our show. I'll leave you with pictures of Chile's Atacama Desert, known as the driest place on Earth. Well, in early July, though, several kilometers of this arid landscape burst into purple guanaco legs, as they're called, as well as white field lilies, an event that happens only when there's rain. Well, although these blooms occurred a bit early, they're meant to flower in the Chilean spring, but bloomed this year in mid-winter instead.
De verdad, hasta es emocionante ver esto, en medio del desierto, en medio de la nada. Ver esta maravilla es asombroso.
Es una emoción profunda, porque este es un fenómeno único en el mundo. Es realmente emocionante, que llega al alma esta belleza, esta bondad de la naturaleza.